Hi, I'm Jamey Hicks, and I work at Nokia Research, and I've been working on an object storage system for a number of years. And what I'm going to talk about today is the result of essentially a year's worth of work that's really focused on building a persistent database for Qt and for Qt Quick in particular. And I guess I've been working on, I was talking at lunch with some people about things we've been doing related to this that kind of led up to it. Embedded Linux hacker, I'd say since '99 or so. We did handhelds.org and Linux on the iPad. But generally, and I got all into that of being a systems kind of hacker, hardware and middleware and stuff, but wanting to do things where there's a user interface that does stuff for people. And we build things, we find that the whole system's affected by what you're trying to do in terms of what the customer wants, what the user wants out of the system. And even in this database that I'm going to talk about, it's affected by what we're trying to do for the user, what is needed for the developer in order to deliver that, and what we need to do to get good performance out of it. So I'll get into that as I proceed with the talk. But just to help me tailor the talk for what you'd want, I'd like to know a little bit about the audience. Are you working on desktop applications? Embedded applications? Mobile? Cloud? No cloud. One. All right. OK, good. SQL? Any non-SQL, no SQL? A few. Good. They've done some of each of those. And then Qt Quick? Non-Qt Quick? HTML? OK. I'm not going to talk so much about HTML, but we have done a version of this integrated into WebKit, but there's nothing in there currently. But good. So I think kind of the premise that we had in mind, even before we knew that Qt Quick was the language we were going to use for building apps, we always had this kind of same philosophy in mind in how we want to build apps. Is that you can build these really rich applications very quickly. You could get great performance out of them. And you can quickly kind of, then the next thing is, you need data for them. You can quickly pull in data from different sources and integrate that in with your own data, or you're building an app that's using Flickr data. I'll show in an example here. The hardest part actually about using that is getting the data and understanding their formats. We don't have to, you have to do anything in particular to actually store the data, use it later, do caching, do synchronization, whatever you want to do. So in terms of building the database, we started with what we thought the developer API should be, and then we've been backfilling the implementation to deliver that and make it perform well. And we're still working on that, but I'll talk about what we're doing. So back to, I want to be able to write these apps. I can write the GUI with a little bit of code. I want to be able to do the storage part of it with a small amount of code as well. I want to be able to do that quickly and pull in third-party data as I need it, and understanding just enough about that data to do what I want to do with it. And then we've been building kind of interactive applications where there's multiple processes that are communicating through the data store. And so we support that. But I discovered that triggers only work inside the database. I was so disappointed. So we have notifications that let you use kind of Blackboard-style interaction. And then performance. In our work, we have to be able to do the flick 60 frames per second. We have to deliver the data for that at that rate. And so we work back from those requirements in terms of the user interaction, what we have to do in the database to do that. So that's our goal anyway. In this talk, my goal is to introduce CuteJasonDB. The title for the talk is kind of generic, because when we had to submit the titles, we didn't actually have permission to use the name in public. But it was kind of the obvious name for us when we were working on it, so we've been calling it JasonDB. And now that it's a part of Qt as an add-on, it's CuteJasonDB. So I'm going to show you how easy it is to use. And then I just want to convince you to consider using it, to consider using non-SQL for things that don't need SQL, or where SQL isn't necessarily the best fit, to consider in particular this database. And for those of you who are interested, it is an open source project. It's under Qt governance now since yesterday. And so you can get involved with that, and that'd be great. So that's kind of the goals for the talk. And in terms of the outline, I say an object database, and I'll tell you what I mean by that. And then get into querying, because putting stuff in is easy, but then finding what you want is where it gets interesting. And then we'll just jump into some applications to see, what does it look like from the code point of view, because that's what really matters in terms of using it. And so I'll just walk through some examples. We'll convert the QML Flickr demo, and then talk about MapReduce. It's not just for clouds. And one slide to show there is a native C++ interface. But our focus has really been on applications, in my group anyway, is Qt Quick as applications. And so when we work on the API, it's Qt Quick API to this primarily. And then we also need a native interface because we build middleware to plug into that. So in terms of structure, JasonDB, it is a server-oriented thing. I shouldn't say server-oriented. There is a JasonDB process. Applications talk to it. It takes care of the storage. It takes care of notifications. Applications, they create, update, remove. It's a NoSQL database. They query for objects. I guess that's variations. They get objects. One of the things that we added on because it fit our application needs was notification. So you can create an object that registers for notification, and if somebody else creates an object that you're interested in, you get a notification. And so then you can go off and do whatever you want to do based on that. So that's been pretty powerful in the applications we've been building. Just trying to check for time. If I talk too fast, which is a tendency I have, slow me down. Wave your hands. I'm kind of excited about this stuff. So in terms of the structure, so often, you're interacting with web services in terms of applications we build anyway. Even within, you're working with Qt Quick, you've got kind of this semi-structured data. You've got dictionaries, key value pairs. It gets kind of rich. And we don't want to restrict ourselves when working with the data store in terms of those things. So in terms of context, we've been kind of positioning JasonDB as if it's that model, use JasonDB. If you really have structured relational data that you've started with, use SQL, Qt SQL, whichever form you want. I've been looking at embedded, mobile, to some extent desktop applications. And in terms of NoSQL, we're aiming at that. There are good cloud NoSQL databases that scale. We're not trying to build one of those. We're really trying to work on a single device database and really tune it to make the best use of the resources, whatever they are. In terms of why did we build another one? It's again reducing the resource requirements. So we have a good framework that we're using. We've implemented the database in terms of that framework. It should run wherever that framework runs, and it doesn't pull in additional dependencies that you don't necessarily need. And in terms of the status, as I said, the code's out now. We've been working on it for a year. We've been building apps. It runs. We're working on performance and robustness still, but the basic functionalities are there. So it's good shape for evaluation. It's not quite ready to ship products on it, but that's kind of where we're going, is to work on robustness, performance, and make sure we have all the features that are needed before we go for a first 1.0 release. So in terms of objects, we call it JasonDB because JSON is kind of a canonical representation for those sorts of objects. And anything you can represent as JSON, you can put in the database. And we're trying to, because the QML runtime is built on JavaScript, it makes a lot of sense to kind of restrict it to that set. So so this would be JSON notation, a JavaScript object, a Qt Quick object, and you can have key value pairs. They can be strings, numbers, lists, other nested objects, and it can get kind of arbitrarily rich and complicated depending on what you want to do in your applications, or what somebody else did when they were doing creating some data that you might want to use. And so what we do in terms of, let me just jump into query. So assuming you've got some stuff into the database, you want to find it. We have a query language it's derived from a framework used in jQuery. So that's kind of one of our HTML connections coming in, because we did a version of all this in terms of HTML for UI. It's essentially filtering on objects. So you can say question mark, filter on a property type equals song. You can, and then sort it by, so the slash says sort it ascending on title. You can do descending sorts. You can chain together a number of filter criteria, type, name equals Hoban, and then not return a whole object from the database, but pull out fields from the database, from the objects. And so that's kind of the structure of it. It's very simple. We had a project meeting this week trying to make it so that when you write a query like this, if you know the objects you're putting in the database, you know kind of the distribution of kinds of objects. You write a query, you have a very good idea how it's going to perform. You know what the database is going to do in terms of query planning. Well, it's not much planning to do. It's really just you walk an index, you pull out objects, and you match against the filter. So it can make it so that this is, again, making it so that getting back to the performance requirements, that you can write an app, you can have a good idea of what the performance is going to be, and you have good controls over what things you change in order to get the performance you need. So let's jump into an example. So this is this actually started as one of our manual unit tests, and I've just kind of fleshed it out a little bit to make an example out of it. So back to the flicking thing. The basic thing is we want to produce a list model so that when you're working with a collection of data, that you can pull out the items, and the whole view model interaction is using the standard QML model. So we have a JSONDB list model that implements that same interface. So you can plug it into, somewhere down here I have plugged into a list view. There we go, list view pointing at this model. The model pointing back to contacts. So that's all we need to see probably about the list view. So this is a model. We gave it a name so we can refer to it from the view. In this example, you can set the query. So there's an initial query looking for any object that's of type contact. And one thing in terms of schemas, we're pretty agnostic, but we've gotten to the point where it really makes sense for every object to have a type. So we almost require it. Maybe we actually do require it. Type equals contact. In the UI, we can change that, and we'll see that when I run it. And then you expose which fields of the object you want to expose as roles from the model that are visible to QQuick, to QML. And in this case, we're limiting it to how many items it's going to fetch from the database. And that's it. So that plugs in the query. The list model, it does an initial query for you, grabs all the current objects that match the query. It also registers for notification. So if you have an agent running, it can be updating it, and your list view will update automatically. All of that's handled inside the model. So let's see it run. And we have a bunch of data here. Let's see it run with no data. Okay, so this morning I made sure it was all warmed up because when the practice talks, it was all paged out. Okay, so this got a very simple UI. You can add a contact, you can delete a contact. It's just generating random data for it, so there's no actual text input in this UI. So if I click on add contact, we get one, and I can, since that one's selected, I can delete it. But let's add a few. And then down here, as I said, we could change the query. So we can add on sorting by first name, if I remember right. And I might not have remembered right. Oh, and then what do I have to do? Oh, and then we're sorted. Or we can sort on something it doesn't exist in. It doesn't show us any data. Let's just fix that. Ooh, that's very strange. Well, I don't know what's going on there, so let's try it again. Okay, so that's kind of enough of that. So add yourself to the screen. So what's going on here in terms of, I showed you the model side of fetching data. And then down here is the actual, how do we put stuff in? JSONDB.create. JSONDB is the QML element that's the interface for create, update, remove. You give it, we're constructing a JavaScript object there, give it a type, first name and last name, and then it just has some code for generating some random data there. So that's basically it as far as the create goes. So in the basic mode, you don't have to do any schema declarations or anything like that. You just create objects, and then you can query for objects, and away you go. So what else do I need? Let's see. Let's summarize a bit. So we saw how to create objects. We saw how to query objects. We saw how to do a query in a list model. So you can hook it into a view, and then it handles all the interactions between the client and the server, extending that model view controller into the interaction with the server. Similarly, when you have stuff you want to remove, JSONDB.remove. I didn't highlight it in the code, but these are asynchronous. So there's the callback of when you create the object, you get a callback saying what the success, whether it succeeded or not, what the error is if it's an error, what the identity of the object is. The current focus is on a single device, but we're thinking about synchronization with the cloud. So every object gets created with a globally unique ID, so we can do replication, synchronization, and have that all be sound. So that's there when we need it. And then for the notification piece, I'll jump back into the code and we can see that in action. But it's essentially, the mechanics are you create another object that's the notification that says, I want a notification on create, update, remove, or any subset of those of objects that match some query, in this case type equals contact, and then run some code in the client when you get a notification. And so that's what's needed there, and that's used by inspector. So let's go look at inspector. It's just an application, but it's actually one that's really useful in development. And it's included as an example in the JSONDB source code. So this currently is showing all the objects in the database. We have the contact objects, which I created in that simple list model application. And so you can see the first name, last name, the phone numbers, all the stuff that was created from the client. Then down here, the long string, that's the unique ID that's added by the database. Type we specified. And there is an access control model. It's not used in this configuration, but owner is tracked on the object so that there can be access control if you need it. And there's that. And we won't go into the other objects at the moment. So, oh, right. I wanted to show you two things there. I want to show you there is an inspector, so you can kind of go in and drive around in the data without having to write any code. But the other thing I want to show you is two apps interacting. So let's bring it back. And let's just look at contacts. Oops. OK, so as I add a contact here, clicking on contact, so we got 3 there, and then another one showed up over here because both of them are registering for notifications. The desktop inspector actually, as it notices new types, each new type it sees in the all items query, it registers a notification on objects of that type so that it can see all of them. And it's breaking them out by type, because that's often how you want to drive into the data, is look at particular kinds of things, look how they refer to each other, and generally understand, especially when you're working with somebody else's data, kind of what kind of object you're going to get. So that was an example of the notification piece. And then I guess the next thing I want to do is, so I'd show you some code that we wrote from scratch. The next thing I want to show is adapting an application that we already had to use the JSONDB instead of something else. In this case, instead of not storing the data at all. And so I took the Flickr example from the Qt Quick examples, and let's run that. So this is the original version. And it has an RSS model that fetches from the Flickr feeds API, and it grabs two things. It actually grabs XML objects and converts them into JavaScript objects, to Qt Quick objects internally. That's handled by a combination of the RSS model and the code. And then it also has references to the pictures, and so that's where the thumbnails come in. So what we're going to do now is just take the metadata part, that object part, store it in the database. When I look at this and I think about mobile applications, I want to be able to decouple the fetching of the data from running the application. I want to fetch data when I have a connection, and I want to watch stuff whenever I want to watch stuff. So that's kind of my motivation for this example. So we don't need that one anymore. So, and JSONDB is not the only thing that's in progress. OK, so let's look at Flickr code and get the debugger out of the way. So the original Flickr thing is there's a visual data model that's built that points to an RSS model. And that's just a generic piece of code that uses XML thing to pull down XML data and give you a list model. And then there's a view that points to this thing. So what we want to do is replace that RSS model, which is ephemeral. It only keeps stuff in memory while it's running, with a pointer to the database, and to split this into two pieces. One, an agent that fetches data into the database, and two, the UI that shows stuff from the database. So first, let's look at the agent piece. So in order to be quick about this, I'm reusing the RSS model. I already have a way of fetching the data. And so that's the RSS model. And all I've done is here is in the callback from the signal from the RSS model that says it's fetched things, to go walk through the model, which is kind of a funny use of the model, but walk through the model, all the items, and create them into the database. Create objects in the database for each item that we fetch from Flickr. And not do anything to the data. So it's, you fetch the object out of the RSS model with RSS model.get, and then you create that as an object in the database. And the only thing I've done to it is put on a type so that I can find the objects when I'm trying to view them. So that's this piece of code here. So in my best case, when I'm working with third-party data, is I pull it in, I don't change it at all, because if they change their schemas, I want to be able to just track that in one place and not have a bunch of conversion code that I also have to track. But that's kind of the best case. It's not always the case. So let's just run that piece. And I believe, where was our inspector? Don't need that for a while. OK. We'll want something at this point so we can see it, because we're not going to run the UI yet. So let's run the Flickr agent. And right, and I was very lazy. And so when it starts up, it immediately fetches stuff. You can see the log here. It created some objects. And if I hit the all items over here, we now have a bunch of Flickr objects. So the RSS model fetching 20 items. We've got 20 objects. Here's the first one. And there you can see that's the actual metadata that you get in JSON format. From Flickr. And so then you can start working with that data. If you're adapting things, this is the point where you start working, is I've got data, now let's start building the UI for it. And we can hit Flickr again. And now it's seen the types. The desktop model is registered for notification. So sorry, let me do that again. When I click this button, the number of items goes up over there, because it does another fetch of 20. So there's 60 more items showing up. So that's the agent piece now. And then the other piece is the UI piece, and that's actually even shorter. I forgot what I called it. So now instead of the RSS model, we just plug in the JSONDB list model, pointing at type equals Flickr image, the type that we gave it, and expose the roles that this list of roles I pulled out of the roles that were specified in the RSS model. So those are the same. And the visual data model, all the rest of the code's the same. So we run it, the other piece. And so there it is, adapted to running on the data model. Now, if I was being totally honest, I would disconnect the network and run this thing to show it's not connecting from the thing. But we didn't fetch the pictures. So it wouldn't show anything because there's no pictures. So there's one more piece to do if you're going to make it offline, which is after you fetch the metadata, fetch the pictures, and then you can do an offline test of this. But that's really all it took to adapt this application to use, which I just picked randomly, to use JSONDB instead of another list model. But I've been working with some teams building apps, and they've had similar sort of experiences. It's very easy to get used to this. And if this is the kind of data you're working with anyway, it's very easy to use it. Very little code to use it. And then you know, and it fits really well with Qt Quick. And that was our whole goal. So we'll see. All the way back. Okay, so what did we go through there? So substituting a JSON-DB list model, using this, you know, fetching the data that we got directly created into the database without changing formats, so we can reuse it. That headless agent to fetch things. Headless, it had a little UI, but it doesn't have to have a UI. It's just a UI so that I can talk about it. And then adapting the UI to work from the JSON-DB list model instead of some other list model. Okay, so then back to data. So sometimes the data, you know, back to two things: the format of the data and getting the performance you want out of any kind of scrolling views. And sometimes the data doesn't match what you need in that view. And so then, just to confuse things, to go back to SQL terminology, we have something called views, which is, my analogy is they are synthetic objects, the way a view in SQL is a synthetic virtual table. They're all, in the current implementation, it's all manifest views. We actually create objects in the database. They take storage because that was the way I could handle the bookkeeping in the first version, the simplest. But, and because I don't want to be computing them as I'm trying to deliver them to the views as fast as you need them sometimes. So I expect that can change, that we'll have ephemeral views, but right now what we have are manifest views for anybody who that means something to. So in this example, I showed you the contacts case. It has a list of phone numbers, and actually it's a list of type and phone number. And if you want to display just like by phone number with the name attached, then you need a different format. And sometimes pulling it apart you can't quite pull that apart in a list view directly from a model. It's awkward. You have to write a bunch of code, and then that slows things down. So, and we're trying to avoid that. So we're going to write some code. We're just going to run it in a different place. I see. I quit creator altogether. I didn't mean to do that. Okay. So this example is map phone. So I said we had map and reduce. And this is really kind of going back to the functional programming basis for map and reduce, and not the cloud map and reduce, although it has the same flavor. They're all based on the same thing. So a map creates a view. A map is a way to create a view. By each time an object appears in the database runs a JavaScript function that you give it, this map function, and it produces one or more new objects. 0 or more new objects. You don't have to emit an object. But for each one that you want in your view, you emit an object. And so in this map, each time a contact is updated, this map function, it walks through the phone numbers, it walks through the kind of the phone numbers, and for each one of those, it emits a new object where the key on the object is the phone number. And the value attached to that object is the first name and the last name. So that's putting into a form that's directly usable in one of these views. And you may have a bunch of maps, and I see in people I work with, we have a bunch of maps to produce things in the right format for different views. And that way we can shift the recalculation of this stuff into once per object update done before you need the view. And then when you're doing the view, it's really just fetching the data as quickly as you can, or as quickly as you need it, and then displaying it and minimizing the computation that's needed when you're displaying the data. So that's really the motivation for these things. And what else do we need to show this? This is driven by, the input to it is that simple list model. So let me run that guy again. There's probably an easier way to do this, but I haven't learned what it is yet. And map phone, my great name for mapping things. And the desktop model, which I meant to keep running. So we can see things. We want to see what's going on in ways that the UI doesn't necessarily show. Okay, so this one, the update, that installs a map object, which this guy hasn't seen yet. So there we go, fetch that. So I pushed update and installed the map object that we were just looking at the code for that has that map function. It also has what source type and target. Source type it's looking at, target type it targets to. And so that map object is just another object in the database. So all these things that have kind of extra semantics, we've mapped them into the API in terms of an object that has a particular schema. So you create these objects, a map object, it has a source type, a target type, and a function. And that's how we've extended the functionality of the database without making a hairy API for it. So there's that. And we have contact objects, but they didn't show up here because we haven't asked it to look for them yet. I didn't really focus on it in the... We're going to do this query a bunch of times, so I'm going to save it. Phone view. So there it goes. And I was bad, and I didn't tell you what I was going to do ahead of time. But you notice, if you were paying attention, this was empty. This thing is a list model that's looking for phone view objects. We did the views lazily, so until I actually asked for one explicitly, it hadn't computed them yet. So when I did the query for phone view over in the desktop viewer, that query caused the map function to run, which caused it to create these things. And because it's not registered for notifications, it sees the objects. Because it's registered for notification on phone view, it should have triggered already, but apparently so that's not working yet. But basically, with the other thing with views is we do the computation up front. If you have a large collection of things and you're not necessarily using all of them, we do the computation up front, but just when you need it. So do it lazy updates so that if you don't need it, you don't do that extra computation on the server. So if things are all lined up and I have my simple list model to create a new one, I create a new contact. No, things are not all lined up. I don't know. Yes, okay, I don't know. Sorry. So I pushed the button, created a new phone view, so we're up to 5 now. And they showed up over here. And I don't know if you saw it earlier, but I didn't. So let's try it again. There we go. Contact, so then we're up to 6 and 6. And the notifications are happening. When it is watching for phone views, the updates are triggered eagerly because something's watching for them. And it's chaining through the 3 applications. Simple list model creates a new contact, which causes the map to run to create a new phone view. So that's map in action. And it's really handy for, in this case, I was pulling out information from the inside of an object. Sometimes you want to convert formats. So this is back to third-party data. You've got third-party data that you want to pull in and keep track of, but you want to display it in your own format, so you map from third-party to your format. A bunch of things you can do with them. And that's the basic of map. And, oops, PowerPoint. Back to where we were. So that was, my motivation. This is kind of contrived, but give a list that's by phone number and do it without requiring any computation in the list view, list model interactions. And that was the example. So we come back. So I showed in the code in the beginning, but let's look at it again now that we've seen what it's doing. So it's a map object, defines something. A map object is something the database interprets, the server processes. Says it starts with a source type. In our example, it was a contact. Whenever a contact comes in, created, updated, removed, it does something. Created, updated, it runs the map function. And then if the map function emits an object, that's created as an object that's the target type. That was a phone view in my example. And there can be multiple ones coming out of each of these input objects. So you can reformat, you can expose internal data, and I'm not going to talk about it now, but this is where we do joins. Sometimes you do want to do joins. Maybe I didn't say it. In terms of kind of the application we were targeting, I'm kind of looking at reduced, small memory devices. And so doing a join in a query that's coming into, back to our performance thing, coming into a list view, you have to expand a bunch of stuff in memory. It takes a bunch of memory, and there's this big pause while you're doing it. So we don't do that in the query. There's no joins in the query. But sometimes you really do need to join the data. And map is the place we give you to join the data. So we do the joins, and we do them incrementally. So as data comes in, you do the join. And then when you query for the joined data, this virtual data that you've created, that's when you get the results back. And that query is efficient because it's walking an index on that key. So you walk the index on the key. That's very efficient to do. You can match the rate to any views you're producing. And I focus on the views because that's the hard case in terms of the performance, delivering the bandwidth of data. Anything else you do, at least the kinds of applications we've been looking at are really read kind of focused. There's a lot more reads than writes. And we optimize for that performance because that's what you see. But write performance is sometimes a problem, and that's another area we focus on performance. But it's in the server side. It's not so much visible to what the developer does. OK, so I showed update on demand. I didn't show, but you can, if you have multiple kinds of data, you can format them into a common type using 2 map functions, different source types, same target type, and then kind of do a unification of things there. And then the key, the first argument to that emit view object is a key, and that can be used for sorting. You can also create indexes on other properties in that object and sort on those things as well. And that's really map. OK, so let me just hold up before going to the next one. Are there questions about that or anything up to this point? Yeah, hang on a second. Do we microphone? Sorry, I should have prompted you first with the microphone. Actually, if you say your question, I'll repeat it back.
OK, my question is, map produces objects in memory, right? Or it produces new objects?
It produces new objects.
So what do you do with this objects? Are you keep them in persistence?
No, so actually when I said a manifest view, it's actually in the current implementation, it creates them in the persistent storage just like regular objects. And you can have notifications on them. You can chain maps and reduces, which I'll talk about in a minute. This is not the only way you'd want to do maps, but it's the only way we've currently implemented.
Who determines the lifetime of these objects? So you have to manually delete.
Oh, these are sorry, what the question was, who determines the lifetimes of the objects and where are they stored, to get back to the original question. So the lifetime is completely managed by the database. They're stored, currently the only option is persistent storage, and the lifetime is derived from the lifetime of the source objects. So if the source object is removed, then the map object is removed. And that's the contract here with map, is that the lifetime and actually the data is directly related to some source object, and they go together. If the source object is updated, the map object is updated. The mapped object is updated.
And vice versa?
No, it is one way. So it's a function. Any other questions or about maps or any of this stuff up to this point? Are we kind of on the same page?
So how do you determine what's indexed? I assume that the types are like treated specially, but
OK.
Can I define other things to be indexed?
OK, so the question is, I'd alluded to indexes, and the question is, how do you create indexes? So we have another, this is actually more recent than the talk. We have another kind of object, which is to create an index. Just like in SQL, if you want it to perform fast, you need indexes. And you need indexes that match the patterns that you're querying. So we're actually, that's a work in progress. We're defining a way to create an index. There is something implemented, but it's not quite what we need. We already know that it's not quite what we need. But the answer to how do you create an index is you create an object that specifies what index you want. And then the database manages that as well. And in some ways, that's a lot like a view, but it's a simpler thing. We don't chain them. It's really purely there so that when you're querying, you can walk a B tree efficiently and pull out the objects that you want to see. So there's kind of 2 parts to the whole database thing, whether it's SQL or NoSQL, is what kind of data are you putting in? What's the shape of it? And I haven't talked about schemas. And we don't require schemas, but we do support schemas. So if you want schemas for documentation to say, here's what kind of data you can expect to see if you query, you have something that tells you that. And we do have a mechanism for enforcing that, so that if you want to ensure that the data that's of a given type matches some schema, then you can do that. So we support JSON schema for that. Indexes, I'd started off with indexes being an attribute on the schema, but that's not always the right thing. So now we have a way to create an index that's separate from the schema. Okay, so let me move on and talk about reduces. So map we can use to transform objects, and we can extract stuff, so we can get 0 more objects out of one object. In a reduce, we really want to reduce things. We want to collapse objects, collapse data into a single object, summarize, those kinds of things. And in this case, I had shown, I think I didn't collect the first names. Yeah, the example I will show doesn't quite match what I wrote here in terms of what I'm trying to do, but it's, the example I show is, now that phone number thing, I don't want duplicate list items for the same phone number. What I want to do is get one phone number and the list of names that have that same phone number. And so let me see if we can walk through that example in a few minutes. I'll at least show you the code parts of it. So I mean, we start off a lot the same. Since I did just mention schema, let me point out here, the one place we require a schema, and it's partly back to this question about who manages the lifetimes. We require schemas for the target types of views, so the target of a map, the target of a reduce, and the primary thing we want out of that, which is the only thing I put in here, is to say the target type is a view type, and since it's confusing, if both the developer and the database are trying to update these objects, we just disallow it at the moment. And the way we disallow it is you declare a schema that says this reduced phone view is a view type. And so that tells the database that only maps or reduces are going to update this type and prevents conflicts happening between your code updating the object and the database updating the object and then doing things that are surprising to you in bad ways. And as you see, you don't actually, in the schema, since I didn't want to specify anything else, I didn't actually give any constraints on the properties of the objects, but JSON schema supports that, and we support that in the database. So let's see. So that's installing the schema, and the schema itself is a JSON object. Then we create the reduce, and this code looks a lot like the map object, except it has an add and a subtract function. And this is because we're doing this incrementally. So as objects are added, we run the add function, and as objects are removed, we run the subtract function. And those two things are responsible for doing the cumulative reduce of a set of objects into a final value. And this could change, but certainly the shape of it's roughly the same. So the prototype to this is the function receives the key of the object, because you're splitting on some key, the previous value of v0, and the object that's being added in, or the object that's being subtracted. And in this case, it's just collecting together into names. The key that we've used is the phone number, source key name, sorry. All right, source key name, key, which in the previous object, the key was the phone number. I could have named that better. And so we're split on the phone number, and we collect together in this code the list of names that match that same key, that same phone number. And let's see if we can run that. And because I copied the same code, it looks the same. All right, back to here. Let's go back to all items. Press update, which installs the schema and the reduce. And just so you see, there's currently, oh, I already pressed the button, didn't I? There's the reduce. So we've created the object there. And now if we do the same sort of trick and fetch the type, the target type, type equals reduced, phone view. And so when we press the button, we should see a bunch of things appear here. Yay! So that was the first time something had triggered on it and caused the reduce to run. And because I'm generating phone numbers randomly, I don't have any multiple ones with the same phone number. But that's basically the idea. It did create a list of names that match the phone number. Still, we have again, we have the lazy evaluation, the incremental update of it. The incremental update is again back to trying to reduce, especially in the embedded kind of applications, reduce the memory that's needed by the database, give that all up to the applications that need it. And so anything that we do, we try and do in a kind of a fixed amount of storage in the database, or at least no more than linear in the size of the query results. So even in maps and reduces where you might end up with something different, we try and get back to that point. So let's get back and wrap it up. So reduce, again, it's the same sort of object we define. It's a type of object that's interpreted by the database. You tell it what the source type is that you're using as input to this function, the target type, and an add function and subtract function, how to compute the target value. And then the database itself keeps track of all of the bookkeeping of when an object is updated, when the source object's updated, run the map function, keep track of the target value coming out of it. When there's updates or removes, backing things out. Generally, reduce, it's for consolidating information and update on demand. So that's map and reduce, ways of producing views. And I think it's an area that it's probably going to be some changes in the database. But it's roughly, there is that need. And we're trying to produce something that efficiently satisfies the need in terms of the data, and in terms of single device databases and applications. And then just to summarize views, maps, reduces, they're both manifest views. They actually create objects in the database that, in terms of the storage, are just like objects that are created through the create interface, the update interface. In terms of chaining notifications and using them as sources to other maps and reduces, they're just like other objects. But their lifetime and their values are completely managed by the database. OK, yes. 1 minute on. We have a C++ interface. It's asynchronous too. It's a lot like the Qt Quick interface. But you have to type more stuff to declare all the types of things. It's in terms of Q variants, so that we have, that's kind of the Qt equivalent of JavaScript objects, or at least I guess we have QJS value now too. But, and so we have a QJS value overloading of these interfaces. But the interface that we started with when we worked in Qt 4.8 was QVariant, and we still have that. We have QJS value for things that are working directly with scripts. And which overloading you use kind of depends on what this code interacts with. So let me give you a status, and then we can take more questions. So it's a data store for Qt Quick. We're trying to match the needs of the applications that you'd write in that style. It's a style we've been writing since before there was Qt Quick in various formats, but it really comes together with Qt Quick. We think the basic features are done, at least in our use. And right now, in terms of our work, we're focusing on performance and robustness. We've been thinking about replication, synchronization between devices, to the cloud. We've tried not to do anything in the design or implementation that gets in the way of that. We haven't done it yet, though, so there could be changes there too. But it's upcoming work. Right now, the database only does JSON equivalent objects, so we don't have binary data or blobs. But we see a need for that, like the Flickr example. Where am I going to put those pictures, and how am I going to manage those? So I think that's coming. And then the Flickr example, again, this is a general pattern I see in terms of applications I build, of pulling in data when you have connectivity, using in the UI, possibly updating and wanting to push changes back. And so I think there's room there for some generic components that fit in with other list models or with other code. And we can see what the patterns are there and try and build some components that match it, in the way we built a list model that matches a very common pattern. And since yesterday, it's available externally. We got through all the licensing and patent checking and all of that stuff, and name checking. And so it's on Gitorius. It's a Qt add-on, and it's under open governance. Patches come back in through the code review. So it's out there to try out, to make suggestions, contributions, whatever. So I invite you all to take a look and give it a whack. And with that, I have time for questions.
Sorry, me again.
No problem.
You say you have persistent storage at this point. Do you have plans for in-memory?
Right. The question, is there a plan for in-memory? I slightly misspoke, or I guess I gave a more overgeneral response. We actually, we know we need in-memory objects, and we have regular, you can create an in-memory object. We don't have views that create in-memory objects. So another schema-related thing, you can say an object type is ephemeral. I think this is going to change, but we know we need to be able to say there's ephemeral objects, they only get stored in DRAM. And so there is a mechanism for that. The way you specify which objects are stored in DRAM may change. But there is a mechanism for that. And there's kind of an obvious extension of views to that same mechanism for creating objects, but it's not implemented yet. So there's definitely a need. We know there's a need. We will implement it, what we haven't implemented yet. Any other questions, feedback, anything?
I wasn't sure, is there one JSON-DB per device or per application or per...
That's really up to how you want to use it. Is there, whether you have a single daemon per device or per application or per some grouping. In terms of, approaching this, we've built a bunch of applications that do mashups. And in that kind of case, we would envision a shared database with shared data in it that multiple applications are interacting with. And to the point where we actually implemented access control models so that if you have subsets of data that some applications can see and others can't, there's a way to enforce that. But again, there's nothing to prevent running multiple daemons, if that's what makes sense for your use. And there's also related to that, there is a way of having multiple partitions in terms of the files that sit underneath the database. The daemon can talk to multiple partitions. So if you have different storage pieces, removable storage as an example, you can have a partition that's on the removable store. We haven't really implemented the part of the storage coming and going and handling that properly. But we do have the point where I can give you a unified view of two different file system partitions as a single database, for example. So I mean, there's a bunch of configurations there about how you use it that I'm sure we haven't thought of all of them. We've thought of some of them and have implemented some of them. Did that answer the question?
Does this daemon have to be a separate process? So if I'm just, especially in the embedded scenario where there's the performance a bit an issue, especially on startups, so can you actually, and you write an application, you already have C++ parts, can you basically have the daemon as a shared library and start it in the same application?
That is not in the current code. It is something that we're thinking about in terms of, this gets, I mean, in some ways it interacts, I understand the point of view. Let me say, the primary configuration that we've been thinking about is a shared data set where we did need some access control. And so that precluded doing reads and writes on the client side. But in terms of the code, I think a little bit of refactoring and we can restructure, instead of having it, having to run it as a daemon, that you can load it into a process and just directly interact with it through the process. So the client side reads and writes, which would fit the model that you're talking about. And that's something we're actively looking at right now.
Regarding robustness in embedded
Yes.
environment, how robust is it against power loss?
That's
during a write access.
That is our primary concern as far as robustness goes, robustness against power loss. And we haven't done extensive testing. Right now we're to the point where we test it on things and we pull the power out and we plug it back in and we can recover to the last state that was synchronized to the database, synchronized to storage. The last point where you did an fsync. We have MD5 sums or SHA-1s on the metadata for the B trees, and everything's done in terms of these B trees. And we're adding in, again, hashes on the actual pages that are in the database if that's needed. So that's where we're headed to. We haven't done enough testing. We certainly need to do more testing and debugging. But in terms of the B tree implementation, we've worked to get one so that we can get to that point where it's very robust to, anything that hadn't been written to persistent storage when power goes is gone, of course. But that you can get back to a consistent state, you can always restart, and that you can always restart quickly when power comes back. And so that's where we're headed in terms of performance and robustness work. There's two things, and that's one of them. And these two things are very high priority and probably equal priority. The other one, well, it depends. It depends on your point of view. The other one is how much space does it take to manage the database beyond kind of the basic, beyond the size of the objects themselves for the indexes and everything. So those two things are high priority for us because we are concerned with devices with small amounts of memory and small amounts of storage sometimes. So that's a very good question. It is very high priority, but that's one of the areas where I'd say it's worth evaluating now, but it's not something that's production ready. But it is something we're working on actively right now. Any other questions?
This is based on Qt 4.8 or 4748, or is this for targeted for Qt 5?
It is targeted for 5. There's been. Let me re-answer the question. So maybe the question would be, if you wanted to use it in 4.8, what would you need to do? So the things that show up as dependencies on 5 are we use the QJS engine, QJS value direct interface to the V8 engine. Well, wrapper for the V8 engine. So that would have to be changed back to QScript engine, QScript value, and fixing the who owns the objects. So that's actually, it's a really small change in a couple of places. This is because the maps and reduces are JavaScript things that are run in the server or in the, if we get to that point, in the client shared object. So that shows up in 2 places in the code. There's some, in the .pro files, there's some dependencies on it being a Qt add-on, and so it uses some different macros from the QMake facilities. So you might have to fix the .pro file so that it actually installs pieces. But I think it will just build in Qt. Other than those 2 things, I think it builds in Qt 4.8. There's probably other things, but it's at that level. It's pretty generic in terms of Qt, but there are some things that have changed already in between 4.8 and 5. And we've used some of those things. And I guess we'd be supportive of there being, it'd probably have to be a branch that's a 4.8 branch and having that track things. But right now our priority is just to get it as in a single configuration, working, stable, robust, and fast. Back to when I'm thinking about robustness. The current B tree is actually an append-only B tree so that it's easy to see what a consistent state is, that you up to a certain point spin fsync to the disk, fsync being the system call you make that makes sure the metadata and the actual data are written to the persistent storage to the extent that the persistent storage device is honest with you. On some of our fast servers, as soon as it's in DRAM on the controller for the persistent storage, it says, I'm done. And of course it's not done, but in those environments you have power supplies that it's harder to kind of knock them over or something. But generally on embedded devices, that means it's actually written to persistent storage. So an append-only thing, anytime you modify the B tree, you're just adding records to it. And periodically, you have to do a compaction that garbage collects, and that's another step. So structurally, we've worked with a technique that makes it easy to make it robust in that way, and make it easy to understand the code so that we're sure that that's true. And that's something we're still working on, the performance of that and the space overheads of that, and testing to be sure that it really, there's the B tree, and then there's a collection of B trees that represents the database, and that collection comes back to a consistent state. And that's where it gets a little more tricky. But structurally, we're trying to make it so that it is robust, that it works, anything that was written to persistent storage is there again when you turn it back on, and to try and minimize those windows for what can get lost. Anything else? Okay. Well, I'm around if you have more questions. Thank you all for attending. It's been great to be able to talk about this with other people who might use it.